Okay, welcome to part 2 of the notes. Now, before we start these examples, okay, we'll do 1, 2, and 3. Let's just kind of review what you just saw, properties of parallelograms. There's a lot of information here, and you need to know all of these. Both pairs of opposite sides, parallel. Both pairs of opposite sides, congruent. There's my congruent marks. The opposite angles are congruent. The consecutive angles add up to 180. They're supplementary. And then the diagonals, they bisect each other. Okay, now we'll be flipping back and forth with this as we go through these examples. All right, so let's look at example number 1. Find ABC if quadrilateral WXYZ is a parallelogram. If they tell you something's a parallelogram, or if they ask you to make something a parallelogram, we know lots of stuff. Okay, now there's a lot of things going on in this picture. We want to find A, we want to find B, we want to find C. In a lot of cases, it doesn't matter how you start. Let's say we want to find A first. The first thing that's important is to recognize, are you looking at a length or an angle measure? The A is for right here. This is a length. This is part of a diagonal. If you have a degree measure like B degrees, that's an angle measure. 18 is an angle. 31 is an angle. 15 is a length. 2C, notice how that's labeled outside the figure. That's a side length. And then 22 is a side length. Now, one thing we learned, A and 15, those are parts of the diagonal, the same diagonal. We know the diagonals bisect each other. That means that both of these are congruent. They get cut in half. So right away, we know A equals 15. So there's one answer. Now how about the B? Here's B degrees. Let's use the fact that we know that opposite sides are parallel. When you have parallel lines, don't forget about the Z. Okay, I'll label these parallel, top and bottom. The Z, we call that alternate interior angles. Alternate interior angles. When the lines are parallel, so parallel lines implies alternate interior angles congruent. So right away when you look at this, here's B, that gets created by part of the Z, and then this is 31. These have to be the same. So we know that B equals 31. Okay, so we got that one right away. The last one is C. Now where's the C? It's at the top. This is the length of WX. That's 2C. We know that opposite sides of a parallelogram, not just parallel, but also congruent. So I can mark these congruent. That means these are equal. So we know that 2C equals 22. Solve it, divide by 2. We get C equals 11. And that's it. There's problem number 1. So we used opposite sides parallel, there's your Z, opposite sides congruent, and the diagonals bisect. All right, now let's move over to number 2. What you should do here, you should be stopping this as you go. Before I explain it, go ahead and see if you can figure this out yourself, at least set up the equations, and then unpause it and see if we agree. Find XYZ if quadrilateral GEOM is a parallelogram. All right, and right away I see there's a little typo here. I forgot to put, here's GEOM. Okay, so we'll label that. Well, let's see, we need X, we need Y, we need Z. You don't have to go in order. I usually look at the sides first. That's the first thing that jumps out at me. And here's 4y minus 3. That's segment GM. We know in a parallelogram the opposite sides are congruent. So 4y minus 3 equals 17. So I'm going to set up the equation. 4y minus 3 equals 17. Now we solve it. We'll go plus 3. So we get 4y equals 20. Divide by 4. y is equal to 5. Okay, so right away we get y is equal to 5. Now let's see, we need x, we need z. The x is an angle measure, 3x plus 8 degrees. Now the opposite angles are congruent, but I don't know what this one is. All right, so no problem. If I want to find the x, we do have 70 degrees down here. Now they're not opposite each other, they are consecutive angles. Consecutive angles make this kind of C shape. Now they're not the same, they add up to 180. Consecutive angles are supplementary. So we can say 3x plus 8 plus 70 equals 180. And now we solve it. That's 3x plus 78. Combine those. Minus 78. So we got 3x equals 102. And divide by 3. X is equal to 34. Okay, so there's the x equals 34. The last thing that we need here is the z. Well, let's see. 5z plus 2 is this angle. In a parallelogram, what do you know about opposite angles? Opposite angles are congruent. So 5z plus 2 equals 70. So my last equation here, 5z plus 2 equals 70. I'm going to subtract 2. That gives me 68. And then divide by 5. And actually, I'm going to get a decimal. I get 13.6. And that's okay. That's correct. Z equals 13.6. I can check this if I take a calculator here. 5 times z plus 2 should give me 70, and it does. Okay, so that tells me my answer is right. So here we go. There's x, y, z. X is 34, y is 5, z is 13.6. Each problem here is using properties. What's congruent? What's supplementary? That's the question you have to ask yourself. All right, for the last one here, this is what we call coordinate geometry. They give us a graph, and they say for quadrilateral ABCD, A is -1, 3. I'm going to plot that. B is 2, 1. And then C is 6, 2. So here's A, -1, 3. B is 2, 1. And then C is 6, 2. Now I'm going to connect A to B and B to C. And you might ask, well, why did I connect it this way? Because they told me in the problem. They name this A, B, C, D, so I connect them in that order. So part A, find the coordinates of D that make this a parallelogram. Well, to be a parallelogram, it's going to have to look something like this. I'm going to have to figure out where to put that point right there. I can do that because I can count. Opposite sides of a parallelogram are congruent and parallel. So here's what I'm going to do. Let me count from B to C. I'm going to count using slope. Rise 1, run 4. This would have to be the same. It would have to be parallel and congruent. Rise 1, run 4. There's my fourth point. Why can I do that? Because I know that when I draw this, BC and AD have to be congruent and parallel. So I have to count the same way. Rise 1, run 4. Rise 1, run 4. So point D is 3, 4. 3, 4. That's my answer to A. 3, 4. Part B, find the slopes of all 4 sides. Now slope is rise over run. We actually just found AD, which was 1 over 4. Okay, so the slope, I'm going to put little m, AD. And we also found that was the same as BC, because opposite sides are parallel That means the slopes are the same. That's 1 over 4. Now the slope of AB, when I count this, it's rise over run. So I'm going to go down first, down 2, and then right 3. Down 2, right 3. So the slope of AB, down 2 is negative, right 3 is positive, and that's going to be the same slope as DC. Down 2, right 3. So that's equal to the slope of DC. Why do I know it's the same? Because opposite sides have to be parallel. That means they have the same slope. All right. Over here we can put parallel implies slopes equal. Part C, find the point of intersection of the diagonals. Now if I draw AC and BD, those are the diagonals. They both bisect. Diagonals bisect, that means they have the same midpoint. Bisect is the same midpoint. So the formula, I'm going to use a formula here. I'm going to use M equals x1 plus x2 over 2. That's the midpoint. y1 plus y2 over 2. So to find the midpoint, I'm going to come down here. The midpoint of AC, I'm going to use point A and point C, which was 6, 2. Midpoint of AC equals, I'm going to add my x's, x1, y1, x2, y2. So the midpoint of AC is I add my x's, negative 1 plus 6 over 2, comma, add the y's, 3 plus 2 over 2. And what I get is 5 halves, comma, 5 halves. So they're both 2.5, 2.5. If I look at my picture here, that actually kind of looks like 2.5 for x and 2.5 for y. So that looks good. Now if I did the midpoint of BD, and I'm going to do this a little bit quicker here, I'll use the picture, add my x's, which are 2 and 3. Okay, so add my x's, 2 plus 3 over 2, add my y's, which were 1 plus 4 over 2, and I get 5 halves and 5 halves. They're the same. They should be the same. Why? Because diagonals bisect. So find the point of intersection. This is your point of intersection. Point of intersection right there. Okay, the last one is find the distance of the diagonals. Okay, so for part D, let's come over here. Distance, let's use the distance formula. Square root x2 minus x1 squared plus y2 minus y1 squared. So for AC, the distance for AC, big square root, I'm going to subtract my x's. Now I'm going to do 6 minus negative 1. 6 minus negative 1 squared plus, subtract the y's, 2 minus 3 squared. Minus a minus is positive. So this is 6 plus 1, which is 7 squared. And 2 minus 3 is negative 1 squared. Now what happens here is you get the square root of 49. This is positive 1. A negative times a negative is always a positive. Be very careful with the calculator. And that gives you the square root of 50. Now I'll use the calculator here. Let's get a decimal approximation. So let's see, square root, I go second, x squared, there's square root of 50, close parentheses, and what we get is 7.1. When we round it, 7.1. So the distance of AC is 7.1. The distance of BD, okay, if you go through this process again, then what's going to happen is you're going to get the square root of 10. And the square root of 10 is 3.2. Okay, if you don't believe me, you can certainly check this yourself. Go ahead and do the distance formula and see if you verify what I have. And that's it for the notes.